So we looked at slicing strings and we looked at taking little pieces of them. Well, we can also do a little more with them than just grab an individual character. Because already we could use the tools we have to build something like a hangman game. Because we're able to change strings and take one string and pull out like the vowels and put it into another string. We learned how those indexes work. And so we're going to add to our knowledge a little bit. So on page 104, 105, we're going to talk about one called the pizza slicer. So we can actually take not just a single character, but we're going to show you how we can take an entire string and we can grab slices out of it really, really easily. So I'm going to create one. And again, just that common sense here, we're going to make sure we always have our name on there so I know your program. And I know I keep beating that over a dead horse, but I run into that throughout the semester. As many comments as you can put in there is the best. That way we know what you're doing. And it helps you when you go back in and you get a bigger program and you're trying to edit those. So I'm going to come in here and we're going to write a pizza slicing program. And so this one's going to be to show string slicing. And so we're going to create a word, and we're going to say that word is equal to pizza. We know we take pizza and we slice it all up. So I'm going to cheat, and I'm going to grab this piece so I don't have to recopy the typing on it, just because we all know my typing is really bad anyway. So this is our slicing cheat sheet. So this is very similar to what we created with the index. So notice we have an index position of 0, 1, 2, 3, 4, 5. And then we have a -5, 4, -3, -2, -1. So they're the same positions, just like we did before. Well, now instead of just looking at it with a single character, though, we're going to look at how we can take an entire chunk out. And so I'm going to put in a print statement. Please enter the position where you want to start slicing. And then I'm going to take that here in just a second. So I'm going to do something really clever. And so the first thing I'm going to do is I'm going to create a variable called start. And if you're following along in the book, we're over here now on page 106. And we're going to give you another little handy thing that Python does. And so I want start to be blank, but I can do something else. Instead of just putting in blank quotes, what if I do this? And I could say that start is equal to none. If I remember to hit the caps lock, it actually helps. And notice when I type none with capitals at the beginning, it actually changes to that orange. That tells me that it's a key phrase. And so start really says, it gives it a null value. And if I had an if statement and I ask about it, it's going to say that it's false all the time. So it's a really great way we can put in a blank line and we can do something a little different. So now I could put in a loop. And so I could say, while start does not equal a blank. Now, so notice there's a subtle difference. So this is kind of a null character. This says it's blank. So there's a slight difference there in there. So while start does not equal a blank input, then I'm going to say start equals input. Enter your starting point. And so we have that start then is equal to where we're going to begin our slice at. We need to do a couple of things in here though. So because we get a value input, and we take it in as a variable, but we need it as an index. So we're looking at that index position. So we need to convert it to an integer. And we're also going to do a couple of other things. So if start, so if there is a value in start, so if it exists, then we're going to do this set of operations then in this block here. So we're going to first set it equal to its integer value. So the integer value of start. And we're also going to then get a ending value. So we're going to take ending value, and we could just convert it all at the same time. We could say input, please enter your final value. If I need to put a space in there, it's going to look a little weird when you start typing. So I need to make sure I have both parentheses in there. So we've got a start value, we've got an end value, and so now we can print what part of what you're looking at here. So we could print the start and the finish and see what you've ended up with. So this is the, need a quote mark. This is the slice from your word. And then I'm going to print. And so in this case, I'm going to then take word, and notice I'm going to use that square bracket, and I know sometimes it's hard to see on the screen, the square bracket, and I'm going to put in the values of start to finish. So all of that is inside of that block, and then I'm going to put in my input to hold my program open. Back all the way. So what we're doing is we're taking a slice of this. You're saying I want position 1 to position 3, and we're going to be able to slice that into different pieces. So let's make sure it runs, and I'm going to call it something. So under Documents, under Python. Something weird. Heaven only knows what I type when I'm talking. So please enter your position where you want to start. I'm going to put it at 1. And the final one is 3. The slice from my word is IZ. So, and because we didn't ever enter a blank value, notice that I can keep doing this then for a while. So I could say 2, 4, and I can get different slices from my original. So 3, 5, and so I'm just taking slices, or I'm taking those index pieces from one portion to another. So it gives me a really, really interesting way to do that. And because I made this code fairly modular, so yes, I have this cheat sheet, and we could make that go away. I could put in any word. So if I wanted to use Peru State College, I could do that. Now my slicing chart isn't going to necessarily work, but I could run this. So my cheat sheet isn't really long enough for the word, but I could do 5, and now it says state. So the values from 5 to 10 are the phrase state. So if I did 11 to 17, and it's going to give me college, or part of college anyway. So we can slice up our text strings pretty easily. And so this is a great example of how we can do that. So there are some shortcuts, and you'll see on page 108 that slicing shortcut. So we can actually do that colon that we see in here. So we're saying from start to finish. So you're putting in the values in Word indexed from start to finish. And we didn't have to go through all of this. We could just have a very simple we could put in a print statement right up here after our word where we assigned it a value, and we could change that and say we want to print word 5:11. So we don't need anything fancy to test this. We could do it this way also. And notice it printed that state, which is what we ask it to do right here. So we can get it to do all these kinds of things. So if we can address individual elements inside a string, maybe we can use them to store additional items. And so what we're going to do is introduce something called a tuple. And so a tuple is really our first attempt at storing data in all of these boxes. So right now we have a string, and each index piece has an individual item. Well, if we made it a little bigger, we could think about storing an individual word in index 0, index 1, index 2. And so the way we're going to do that is we're going to introduce you to our friend the tuples, and we're going to show you how we can do a list of items. So this one's called Heroes Inventory, and it begins on page 109. So now we're going to show what a tuple looks like. So down here, a tuple is really hard to do. I'm going to create one right now. Inventory equals, and I'm going to do an open and close parenthesis. And when I do that, I've created a variable that can store multiple items. And I can do some other things with it. So because it's a place in here, I can say, so if not inventory. So bless you, by the way, over there. Don't die on us. Allergy season's great. So if there's nothing in inventory, if not inventory, I can print you have nothing of value. And so right now, if I ran this program, that's what it's going to do, is it's going to say, you have nothing of value. There's nothing in that inventory list yet. And so it gives us a handy way we can store things. And so I'm going to flip the page, and we're going to look at, I want to put some items in there, and how can I do that? So I'm going to multiply or change that. So now I'm going to say, now I'm going to add some items in there. So I'm going to change inventory. And so down here I'm going to say inventory is equal to, and this is where that white space gets kind of a handy thing to do. So I'm going to add a sword to his list, and I'm going to put a comma. And just to make it easier to read, I can jump down to the next line. And so the next thing, maybe he has a shield. He's very contemporary. He's got an iPhone. So whatever items we want to put in there, we can throw 3 or 4 or 5 or 10 items in there. Maybe he's got a motorcycle. So I can create that list of items. Now if I did this, and I could say, this same statement would say, all right, now I have items in there. Well, I want to be able to print those items out. So printing my tuple. And so I'm going to print inventory. And notice I could clean this up and make it very pretty, but what I'm really looking for is, do I have all these items in there? So now I'm going to run this again. And so it says, you have nothing of value. So at the first piece, it worked. It looked at that. Then we changed inventory. And now we have a sword, a shield, an iPhone, and a motorcycle. So we've added some pieces into your list. Just because it'll drive me crazy. Alright, so we can also print these items individually. So when we printed it, it printed that list, and it looked a little funky. So it showed us that list separated by commas and the single quotes. But maybe I want to print that list individually. So our for statement that we got introduced to, so for item in inventory, so for each piece in inventory, so this item is our counter, then we could print item. So let's see if that works. We'll run it. And now it printed it as a list. So shield, sword, iPhone, and a motorcycle. Well, we've got those tuples are kind of a great thing. So now we can store multiple items in a single variable. So if I had a list and I called it student, so now I could say student equals, and now I could put everybody's name in there. So Jason is in our class. Mary's in our class. So I could create this list of individuals, and I could put them all inside one individual variable. Well, that one's pretty handy. And we've looked at how we can do these in a loop. So we've said, all right, well, now we can loop through. But maybe we want to manipulate them a little bit, and we want to do some additional steps with these. So we have a couple of other things we can do with these. So not only can we get into them, but maybe we can manipulate them. So I'm going to leave my inventory the same. In fact, I'm going to get rid of this top piece because we know we can check if there is anything in there. So I'm going to print inventory, and in fact, you could put a print statement above that, and you could explain what you're doing. I am printing your inventory. So it would be kind of handy to know how many items are in this inventory. And so that length statement that we used before, we can also use that in our tuple or our piece of traffic here. So we have, let's just do a print statement. So print, you have, then we can do a length of inventory. Items. So now if I run this, it should tell me either how many items I have or the length of the entire string. So let's figure out which one it's going to show me first. What did I do? Oh, all right. So I am printing your inventory, so it prints out sword, shield, iPhone. But then it tells me I have 4 items. So the length doesn't tell me the length in number of characters. When I do this on a tuple, it tells me how many items I have inside of there. And so that's on the bottom of page 113. It actually then we can look at how many items we have. So maybe we can search through our tuple. So one of the other things we might want to look for is we want to look for a specific item. So I'm going to come down here and put that under a chunk for now, just so it doesn't do anything for us. So the same thing we did before, so we can put an if statement. So if, and maybe the key phrase we're looking for is motorcycle. Alright, so if that is in inventory, then we can print spring days are great to ride in. Else we could print something else. So we can do that, and we can see if, and it says you have 4 items, press the enter key. So my guess is I spelled something wrong, and I can't really see individual characters on here as I'm typing blind on this sad old monitor up here. So I'm assuming I spelled motorcycle wrong in one of the places there. But if I did the same thing with shield or any of the other ones, you'd be able to see if it did that. So S-H-I-E-L-D. So if shield is in inventory, then it should be able to print that. So we can actually check. So yep, spring days are great to ride. So it looks through that entire list, so we can use those in pieces pretty easily. So we can slice up our tuples also. We can do some really crazy things with slicing them. We can display one item at a time. So if I wanted to print one item out of our list, so I could simply do a print, and I could, the same way we did with those individual characters, I'm going to print inventory, and I could actually print then individual pieces. So I could say I want to start and I want to finish, and so I could put it from item 2 to item 4, and it's going to print those items. So we can run that, check it again, except for whatever I did there in my invalid syntax. What did I not do? Oh, forgot to end it. Duh. All right, so now it's going to print iPhone and motorcycle. So between 2, so it prints this, and it'll print that out. So we can slice up these tuples any way we want to. Now, there's one problem with these tuples. It would be handy if I could assign a value directly in there. So if I'm looking at this and I go, man, I didn't really want the word shield in my inventory. I want to do something different. And I would think I could say inventory, and I could assign it a specific value. So inventory here, so sword is the first one, shield is second, so position 1. And I would be handy if I could then just assign it a specific value and change it. From a sword to what I really need is a machine gun. And it would be great if that worked. But it's going to error out because we can't actually directly put in an item. Well, all right. So what can we do if I want to change this list? So we do have some things we can do. So maybe I create another one, and I'm going to call this one backpack. And in my backpack, I have, let's put dollars. And let's put some gold. And let's add, maybe I have a watch. Well, while I can't add individual items into a tuple or change them directly, I can actually add two things together. And so what I can do is use that plus operator just like we did with words. And so I could say that inventory is equal to inventory plus backpack. And now I could print inventory. So I can concatenate or add them together, but I can't change an individual item. If I typed all that right, so we added those items, so I added the dollars, golden watch, and now all of that is stuff inside of inventory. So I can manipulate them that way a little bit. So this gives us a lot of interesting possibilities. We get some really neat ways we can manipulate strings around. I can always take one out the same way we did with a word character by sliding them into another string or another tuple. So what I would like to do is we want to create something like a word jumble game, where you're going to take a game and it's going to scramble up a set of words and it's going to output that word and you have to then guess what it is. And we have all the tools to do it. We just have to kind of put them together. So I'm going to clean out all of this junk here for now. And so I'm going to now call this one my word jumble. And this one's probably our most complicated program easily by far that we've done yet. So a couple of things we're going to do up front. So we know that this one we're going to scramble things, so we're probably going to need our friend that random library so we can do that. And we want to create a list of our words, and we can put those words inside of a tuple. And so to make life easy, just because we know we're not going to change them, I'm going to call them words, and I'm going to do them all caps. And again, Python doesn't really respect that as a constant, but we can respect it as programmers here. So we're going to add some words, and I'm just going to steal the same list that our book has to start with, just to make life easy. And so we're going to put some items in here. So we're going to put in the word Python, jumble, easy, difficult, answer, xylophone. But we can add others. So we're not limited to this list. So we can add Peru. And we could add college. So we could have our list of words up here. And these are all then shoved inside of this construct. I'm trying to make this a little bigger. So we got our list of words. And those are the words we're going to scramble and create our content with. So the first thing we need to do is figure out, how do I pick a word randomly out of there? And so we're going to show you something that's really pretty slick. So I'm going to say word, and notice those are two different variables. So capital is different than lower. So we're just going to say our word that we're going to scramble and make you guess. Well, I'm going to use random.choice. So another thing out of the library, and I'm going to send into that choice, I'm going to send into it that tuple words. So now word is going to print out, and we can always look at this and confirm it. So print word lowercase, and if I save this and I run it, so the first time it said answer. Well, I want to run it again and make sure it's going to give me a different one. College. So again, we could do this in any language. Python makes this amazingly easy because we have this random choice, and we can actually directly access this tuple, and it will just output one. In a lot of other languages, we would have had to figure out how long this is, and then pick a random number in that length and access it. So we could do it, but this makes it really, really, really easy. So we created, and maybe I'll put in a comment here so I know what I'm doing. So the statement below picks a word from our list. So we don't need that print, but I'm going to leave it in here with just a comment tag so that if I need to pop it back in, we can do it really easy. And so now we need to figure out how to create a jumbled version of that word that we have. So this is probably the trickiest part of the entire thing. So I'm going to create a blank variable. I'm going to call it jumble. Because that's what we're really doing. You could call it anything you want. And I'm going to set it up as a blank or empty character string. So we know that we can use those loops, and we can do a loop that will go through every character in our chosen word. And so if I just use while word, so while word exists, so in other words, if I say, is there anything in word, any letters left, this loop is going to continue. And the reason that's important is we're going to actually kind of do some interesting pieces. So we're going to do another variable called position here. And position we are going to get from where that word is. So we're going to take some individual letter out of word. That's what we're going to do, is take them one by one randomly and create a new word. Does that make sense? We can't change the value of word itself, but I can pluck out a character one at a time. And so position is going to equal to random.rand range. And that random range, we're going to base off the length of word. So in other words, this will work for a 3-character word, or it would work for a 300-character word, because we're asking it which one we're going to have here. So because I want to see what's going to happen, we can actually do print position. So right now, if I run this, it'd be helpful if I put the parentheses around there. Got excited. So if I did this right now, notice it's just randomly grabbing numbers left and right. And they're all in that range. So 2, 1, 5, 6, 0. So we're getting all of those. So as long as that word still exists, great, we have it. So we're getting a list of random characters inside of our word. So we could then say, so jumble equals jumble plus word, and slide in that position value. So in other words, we're getting a random index value out of that word. But here is where it's kind of interesting. So this would run on forever, and we would just keep on scrambling those, but we need to slice out that letter that we just stole from word. And so we're going to actually change the value of word. So word is going to be equal to word, and we're going to use a little shortcut. And so we're going to say word is going to be up to the value of position. So in other words, if it's position 2, it's going to be 0 and 1 are going to be included. And then we're going to add it to word. And this one's going to be the little tricky spot. So what we're going to do is go one past where we started at. So it's going to be position plus 1. And notice I had to put those in there so that it would go around it. Word position 1 plus 1, and then we're going to do it through. So it's going to get everything except that letter we just took out. So it's a clever little bit of code. Let's see if I have my, I can't hardly see what I'm doing here? Oh, all right, hopefully that's right. So what it's going to do then is each time as it goes through there, it's going to add one more character in it. So one of the things that's kind of handy to do is we can go in and we can create it and look at it as it's going. So we're going to add in a print statement. We're going to see what it looks like then as it's creating this value. All right, so get rid of that. So I want to print word. Get rid of my one I know has a typo in it. All right, so now each time it's going to print me a position, and it's going to print that word as it develops. So that maybe will make more sense as we run this. So it actually grabbed Peru. So word, it first grabs position 1, which is the value of E. And so it reconstructs it minus the E. Then it takes 1 again, it guessed, and it takes out now the R, because that R is now in the 1 position. Now it takes out the position in 1 again, so it took out the U, and then it finally took out the last character. So at this point, there's nothing left of word, so that loop exits. Yeah, well, pretty slick. So the other piece we can do is we could actually print jumble and see what it's doing at the same time. So we run this again. So our jumble then, this is the word we originally started with. So it picked jumble and it took out the E. So the E then becomes the first letter in jumble. And then it's EJ. And so notice at the end, all we have left is a scrambled version of our original word. And this will work for anything. We could put in a word. Just throw it in here. Supercalifragilistic. And it's still going to work. Now our chance of getting that one's probably pretty slim, but so in this case it did a different one. Not sure what our chance of hitting that one's going to be. There it goes. So there it took our longer word, and you can see how it broke it down, and it went from an unscrambled word to it scrambled it. So this is a clever little piece of code that our author has created to do that. So now we have the ability to have a scrambled word. And so since I have these in here, I'm going to just hide them for now. So again, I know what they are. They're used for testing, but nobody else will when we look at it. So now we can actually create the guessing part of our game. And so our guessing part of the game then is actually the easy part, because we already know how to do all that. That's something we've done already. So if we want to look at this then, so now we could say, all right, I am going to do a print statement and say, now is the test of your intellect. Can you unscramble the word? And so now we could say, the scrambled word is we know that it's the word jumble. So now it's going to print out the word for them to guess. So now we need them to take some kind of a guess. So guess equals input. Please input your guess. So now we could create a loop that they could guess that multiple times. So while guess is not equal to and we have to come up and figure out what that word actually is, though. So there's the one part that is a little different we need to think about. So we don't have any way to tell what that original word is because we destroyed it, right? So up here where we said word equals random choice, I can also use another variable, and I can say maybe correct or the right word, whatever you want to use, is equal to word. So now I have saved a copy of word. So while guess is not equal to correct, and we could also give them an escape. So if they've never been able to guess it and they just hit the enter key, we want to be able to let them out. So we can put this as an and guess does not equal a blank entry. So both of those conditions have to be true. It can't be correct, and they can't have just hit the entry key. You can say, all right, print, sorry, you are not correct. And then, because we're in this loop, we'll just grab this statement up here and copy it. We'll put it inside the loop. And so this will keep asking over and over and over again. So right now we could check it. We could say, okay, let's try. So now is the test of your intellect. Can you unscramble the word? The scrambled word is, I have no idea. All right, so I'm going to enter a guess of 1, 2, 3, 4. Nope. So I'm just entering things randomly, and notice I can do it forever until I hit the enter key and it exits me out. So that actually works. Now I see something that would drive me crazy. I need that space in there. But we also want to say, if you guessed it correctly, did you win? So we could put in there, if guess is equal to correct, then you could do a print statement of, congratulations, you are a winner. And then we could do an else statement. Sorry, you could not guess the answer. So now we have both a start and a stop. So you could add to it, make this much cleaner. I've just thrown this together really quickly, so let's make sure it works. So we're going to click Run. And so it says, can you unscramble the word? The scrambled word is, don't know, let's try something. Enter a guess. Nope, 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 nope. And it says, sorry, you could not guess the answer. And again, I would clean this up before I turned it in, make sure all my spelling's right, make sure I have spaces correct, probably add in really nice language. But what we're looking for is the mechanics. Does that mechanics work? So F5 again. And can you unscramble the word? And I'm going to type jumble. And it says, congratulations, you are a winner. So the mechanics of this work, and we could add additional words in here. So we could put in additional words. We have some pieces here where I put in a guess, and it doesn't look very clean, but we can do a lot of those things to clean it up. So this logically then works. So we need to clean it up, but it's our first really working game that we can do something interesting with. And you can, like I said, you can change that. And we could put 100 words in there, And it really doesn't matter how many different words we have in there. So this logic and how we scramble those words kind of comes into effect. So your assignment this week then is you're actually going to modify this program. So one of the things we want to do with this program to modify it is maybe we want to count how many times they go through there. So you have two pieces. So you need to modify it to have some kind of a counter or a scoring system. So it would be pretty easy for us to add in a counter every time you guess. So maybe we could just put in a variable of counter equals 0. And then every time that you took another guess, counter equals counter plus 1. And then you could rank their score based on how many chances or guesses it took. So if it took somebody 37 guesses, you could come up with a ranking list. And maybe even down here, congratulations, you're a winner. And then you could come up with some kind of, if counter greater than 20, here's a print statement. You are horrible at this game. So, and then you could do like an LF, and you could do it in different ranges. So that's one way you could come up and you could change it. So some way to do a scoring aspect. The slightly harder piece is to come up with a way that you could offer hints to our users. So how do you offer a hint to your users? And so I'll give you a clue. One of the easiest ways to do it is something called a parallel array structure. So if I know what position this is in, I could have another list of things, and I could have hints, and I could then, if you ask for help, so somewhere in here I have a let's get help stage. So maybe you have input, do you need help? And you could have a second piece that's going to come in here and might be a good place to fire that off. So you can ask them a yes or no question. So do you need help? How do I add that piece in there? So there's a lot of different ways to do this, but there are some fairly clever ways you could do it. So think in terms of scalability also. So one way that I will not recommend to do it is you could set in here, so you've already asked them if they needed help, and they said yes. So you're inside a block of code, and you could say, if correct is equal to, and you could do each one individually. So difficult, and then you could print out a hint for each one. The opposite of easy. So that would work, and you could do a set of LFs. Correct equals, what's one of our other words? Peru. Print a country, a college. So you could go through and you could do those, and you could put in a set of LF for, and so one for every possibility. But the problem with that is that's not very scalable. So it would work with 3 or 4 or 5 words, but what if you decided to add 100 words to the jumble? So there are some students who have come up with over the years for this kind of problem. Some very clever ways to solve this and look at it. So some of them have used slices of the word. Some of them have created some very elaborate text hints and ways to go back and do them. I think the easiest way is through the use of those parallel tuples. So in other words, there's some way I can create another list. I'm going to go up to my list of words. And so maybe I have one called hints. And inside of hints, I have a hint for everything. So Python might be a deadly snake. A jumble might be the same as scrambled. And then you could set up a list of hints that way. And how you access those might be an interesting exercise. So there's hundreds and hundreds and hundreds of ways to do this. Some are better than others. So one thing I would like to encourage you is to think about that idea of how do I make this as scalable, or in other words, as expandable. So if I want to go in and add words to my list, how do I make that hint also match those easily? Because in a typical word jumble, you're not going to have just 5 or 10 words. So if I created this where I wanted to scramble thousands of words, how could I also do some hints with it pretty easily? So that is a challenge for you this week. I know some of you have already been working on it. And in fact, I have a couple people that have actually turned in some submissions. But the other piece I will make sure you're aware of is make sure if you don't have this original game, you can create it through the book and make sure it works. You can also grab a test copy then from Course Documents. There is a zipped folder in there with essentially all of the book, quite frankly, except for the problems we're going to work. And so there is a working copy of it that you can find in there. Now, make sure when you use any of these, make sure you put your name in it. Make sure you change this so it works really well. One of the things I would think about doing is we now have the ability to use those upper and lower. So you've seen the dot upper, dot lower. So use those when you take input. So if I typed in the word jumble all in capital letters, it's not going to score that as correctly. So think about, do I have an easy way I can convert input into either lower or uppercase? Is there an easy way we've learned now that you could take the answer? So if I have an input, so maybe I say input, please enter yes, no. So what I would like to do is I would like to be able to interpret it whether they type in yes, yes, capital, I can do it here, or if they just type the letter Y in there, or Y. So I would like all of those possibilities to work. Or as long as they typed a word that started with a Y, can I take that in there? So you can make your program more robust by adding in these little small features. So how do I take that and interpret that input statement correctly? So down here where we do we're getting, back away here. So where we're doing this jumble and we're asking for their input, if they type in a capital letter, it's not going to be correct. And so if you're designing this for a system, think about on your iPhone or your Android phone when you start typing, a lot of words it automatically capitalizes. Well, there are ways we can clean up that input so we always get lowercase so we can do a comparison between the two of them. So start thinking about that idea of robustness and scalability. So even though these are small little programs, they give you those ideas that we can expand on as we start building those out.